warahmatullahi wabarakatuh. The first thing for today is going to be the things that we are going to learn in operation of algebra. Right, so now I'm going to ask you to see what I have here. These are the subtopics that we have in operation of polynomials. So basically today's topic will be related to operation of polynomials. So when we are saying that it is involving operation of polynomials, so in your mind you can expect to have the operation that we have in our normal life, which is the addition and subtraction, the multiplication, and also the division. So basically that is what we meant by the word operation of polynomials. Okay, but before we proceed into further details of the operation of polynomials, there are a few things that we are supposed to understand, which are about the terms or the types of polynomials that we have. Okay, we can have the word monomial to represent one term of the polynomial, and then this is referred to one, mono. And then when we have more than one, which is two, we call it as two. We call it as binomial, which is referring to two terms in the polynomial. And when it comes to three terms in the polynomial, we say it as trinomial. And the one which is more than three is what we call as polynomial, which is many nomial. Okay, so basically this is the terms that we have in order for us to identify the types of polynomials that we have. Okay, I'm going to show you the example that we have in our module. So this is the example for the types of polynomials. The first one that we have here is a monomial. Okay, so when it comes to a monomial, you can expect to have something in the form of ax to the power of k, where a is a constant and k is the power of the integer. I mean k is a is a constant and k is actually the power, and it have to be with the power of which is bigger or equal to 0. Okay, so the minimum power of the unknown is supposed to be 0. It cannot be a negative integer. Alright, and then the second one is a binomial. So when we say that it is a binomial, it is either the sum of difference of two, the sum or difference, meaning the addition or the subtraction between two monomials. Okay, so from one monomial just now, from a monomial, we can expand it into two monomials, which is what we call as binomial. Okay, so this is the example of binomial, which you can see that we are actually having two different terms. So 2x to the power of 3 plus by 2. So the operation that we have here is plus. Okay, so this actually separate two different monomials. Okay, two different monomials with different power, which is with having different degree. Okay, and then the third one is what we call as trinomial. Okay, trinomial is the sum or difference of three monomials with three different degrees. So this is the example that you can see. We have 1, 2, and 3. Okay, so 2x squared plus 5x minus 6 is an example of a trinomial. Okay, and the power of every unknown that we have here, the power of the unknown that we have here, this is to the power of 2, power of 1, and power of 0. So we are having three monomials with three different degrees. Okay, not to forget to understand the meaning of the word degree and leading coefficient. So the second part in this topic is to understand about the degree and coefficient. Alright, so this is the second part, which is trying to understand the degree and the coefficient of the polynomials. Okay, so look at the example for the first one. Px equals to 5. So this is also considered as a polynomial or a monomial, which is having 5 as a constant. Okay, 5 as a constant. What can you understand with 5 as a constant? let's say we write it over here, px is equals to 5. Okay, so what you can understand is that 5 is multiplied to x to the power of 0. Okay, why? Because this is actually considered to be 5 multiplied by 1. So x to the power of 0 or anything to the power of 0 is equivalent to 1. Okay, so this is also an example of a monomial or a polynomial which is having the coefficient of 5 and the degree of 0. You can see that the degree of this polynomial is equivalent to 0. Okay, look at the second one now. This is the first one. What about the second one? Okay, the second one is given as px equals to x to the power of 4 minus 1. Okay, so just now we are having a monomial. Okay, if I can put the word, this is a monomial. This is going to be our binomial. Okay, and this binomial having the degree of, okay, what is the highest degree of the unknown that we have here? The degree would be 4. And the coefficient of the leading coefficient of this polynomial would be equivalent to 1. Why is it 1? So because of this one is actually 1 multiplied by x to the power of 4. Okay, this is not written anything, but we can understand it as 1 multiplied by x to the power of 4 minus by 1. So the coefficient, the leading coefficient is 1, the degree is 4. Okay, what about the third one? The third one is written as px equals to 1 over x and plus by 12x. Okay, so this is not considered to be a polynomial because of we can understand that this is something that we can write as x to the power of negative 1. Okay, so remember our polynomial have to be with the degree of 0 and above. Okay, polynomial is this is the thing that we are having. Monomial is of the form of ax to the power of k, where a is a constant and k is bigger or equal to 0. K is bigger or equal to 0. So this is a very important point to understand that k have to be bigger or equal to 0. So therefore, if we are having a negative value over here, the power of the unknown is a negative value. Therefore, this is not what we call as a polynomial, not a polynomial, right? Okay, so we cannot, or we don't have to find the degree and we don't have to find the coefficient, right? So this is the first part of the topic. Right, we are going to move on now to the next part, which is about the operations involved in polynomial. So I would like you to focus on the operation that we have here. Okay, we are having more than one operation, of course. So the basic one that we have is about the addition and subtraction, and then we can also have our multiplication. Okay, addition and subtraction, multiplication of polynomials, and also the division of polynomials. Okay, so the new one that we have in this topic is going to be this part of division of polynomials, right? This is something new to you, about the part of division of polynomials. The rest of the things are not that new to you, especially the part of addition and also multiplication. If you can relate, the one that we have for addition and subtraction is when it comes to the like terms, we are going to add the like terms and subtract only the like terms. Okay, what about multiplication? The process of expansion of two brackets is also considered to be a multiplication of polynomials. Okay, so we are going to see the example that we have in our module now. Right, so this is the one that we have. Okay, so when it comes to addition and subtraction, what we can do is we can see that we are given the first polynomial over here, which is the first bracket, and then we have another bracket over here. Okay, and the addition in between is subtract or addition. So this is addition, this is subtraction. Okay, so for us to simplify, of course, we are going to remove the bracket and put the like terms near to one another. Okay, so we are going to put the like terms near to one another. For example, for this case, 2x squared and x squared. So it is going to be added over here, and 3x with minus 2x, 3x minus 2x, and negative 4 and plus 5. Okay, negative 4, which is minus 4 and plus 5. And at the end, when you simplify, you get 3x squared plus x and plus 1. Okay, the same goes to the operation of subtraction. You just put the like terms together and you rearrange back so that the degree of the polynomial is written in order. Okay, the highest order, the highest degree is supposed to be written first until the end, which is the constant with degree of 0. Okay, so that is for our process of addition and subtraction. Okay, we can also write our process of addition of polynomials as this one. Okay, you are already given that px is equals to something and qx is equals to another thing. And we also have rx over here. So this is just the name given to every polynomials that we have. Okay, so when you were asked to add px and qx, what you need to do is you just copy back your px polynomial of px, and then copy back your polynomial of qx, and the operation in between is addition. Okay, so this is what you have here. Okay, and then the process of eliminating the brackets and put the like terms together. Okay, the same goes to the second question. This time around we have 2px minus rx. What does it mean by 2px? You can understand it as 2 times by px. 2 times by px. So you can just put 2 outside the bracket and the polynomial can be copied again and minus by rx that is already given from the question. Okay, and then you expand the bracket first and you find out the like terms and simplify at the end. Okay, so you can see that this is just a normal process that you have done before, right? The next one for now is going to be a multiplication of polynomials. Okay, multiplication of polynomials. Right, when we are saying that it is a multiplication of polynomials, you can just put your polynomials side by side and you can either write the operation of multiplication or you can just put it as in the form of brackets like this. Okay, right, so when you see that we have two different brackets, okay, we can just expand. Okay, of course the process of expansion is the one that you have already understand before, which is 3x multiplied by x squared, and then we have 3x multiplied by 2x, and then we have 3x multiplied by negative 3. Okay, so that is what you get for the first one. And then the next process would be having the next one, which is negative 1 multiplied by x squared, and then we have negative 1 multiplied by 2x and negative 1 multiplied by negative 3. So this is what you get for the second part. And at the end, what you do is also to put the like terms together and simplify. Okay, so multiplication and addition and subtraction are very familiar to us before, right? So the new one that we have here is about the part that I have already mentioned earlier, which is the part of division of polynomials. Okay, for us to have a division of polynomials, we are going to understand that it can be written as before. Okay, it can be written as the one given below. Okay, so we have px is divided by a polynomial which is dx. A polynomial px divided by is divided by a polynomial of dx, and you'll get a polynomial which is what we put as qx, which is the quotient, and we have the remainder of Rx, and also the quotient, the divisor of dx. Okay, right, so what is this? This is the quotient, this is the quotient, this is the remainder, and this is the divisor. Okay, so when you want to rearrange or you want to eliminate the divisor, you can also put it as px is equals to qx times by the divisor plus by the remainder. Okay, so this is just the fraction form of your division of polynomials. Okay, so process of doing the division of polynomials can also be known as a procedure of what we call as a long division. Alright, so it is a kind of long division. Okay, I'm going to show you this example here. Right, before we proceed, you can see that the one that we have as the numerator is divided by the divisor of x squared plus 3x. Okay, I would like you to see that we have the highest power of the numerator is 3 and the highest power of the denominator is 2. Okay, and this is supposed to be understood that the numerator power is supposed to be bigger than, okay, the numerator degree is supposed to be bigger than the denominator degree. Okay, then only we are going to do our process of what we call as a long division process. Okay, look at this one. Alright, you have the actual question that we have here is x to the power of 3 minus 2x plus 5. So before you proceed for the process of long division, I would like you to see that we are going to put it as x to the power of 3 plus 0x to the power of 2 minus 2x plus 5. Why do we need to put this 0x to the power of 2? Okay, this is just to make sure that when we multiply with the one that we have here, we are going to have the space for x to the power of 2. Okay, so just write or add on the degree which are not given with coefficient 0. Okay, so for example, just now the first coefficient, the first degree is 3, and then the second degree is supposed to be to the power of 2, but you don't have any, you just put as coefficient of 0 times by x to the power of 2. Okay, so this is the process, and then minus by 2x, which is the power of 1, and plus by 5, which is to the power of 0. So that is just copying back the question. Okay, and then next is to look at what we have here. This is x squared and this is to the power of 1. This is to the power of 2 and this is to the power of 1. Okay, so now we are going to see, for us to divide x to the power of 3 and x to the power of 2, what we can do is we are going to x to the power of 3 divided by x to the power of 2 is supposed to be equal to x. Okay, which is x to the power of 3 divided by x to the power of 2. So this is going to be equals to x. So that's why we put x over here. Okay, so it's just like what you are having or doing for the normal division of numbers that we have before. Okay, so when you put x over here, okay, don't proceed yet. You have to multiply x, and x squared becomes x to the power of 3, and then x times by 3x is equivalent to x to the power of 2 multiplied by 3, which is 3x squared. Okay, so that is just by multiplying back the value that we have over here. Okay, so when you want to simplify, okay, you are going to minus x to the power of 3. Of course, we are not having anything here. X to the power of 3 minus by x to the power of 3, and 0 minus by 3x is equivalent to negative 3x squared. Okay, so this is supposed to be 3x squared. Just correct the typos given in the module. Okay, it's supposed to be 0x squared minus 3x squared. Okay, 0x squared minus 3x squared is supposed to be negative 3x squared, and then we just copy back our value or terms that we have before or after it. Copy back this one below, and then we have negative 3x squared minus by 2x. Okay, so now we have 3x squared and we have x squared over here. Okay, negative 3x squared and x squared over here. So you can try to take out, if we have negative 3x squared, you divide by x squared, what do you get? You'll be getting negative 3. So that's why you put minus 3 over here. Okay, put minus 3 over here. Okay, so when you have minus 3, so therefore when you multiply it back, you have negative 3 or minus 3 multiplied by x squared. You have negative 3x squared, and then minus 3 multiplied by positive 3x is equivalent to minus 9x. Minus 3 multiplied by 3x is equivalent to minus 9x. Okay, so this is negative 3x squared. You have also another negative 3x squared below. So you are just having your minus over here to eliminate the x squared values. Okay, next would be negative 2x minus by negative 9x, which is equivalent to negative 2x plus by 9. So it will be a positive value of 7x. And that is going to be your value that you get from the one above. Okay, after that you copy the one that we have, which is 5, right? So now you can see that we are having 7x plus 5. So if we compare this one and this one, now the power of this one is already smaller than the one that we have here. Okay, this is what you want to divide by the divisor. Okay, so when the power is already lower than what you have here, then you are going to stop. Okay, then you will be stopped. Okay, because we cannot have 7x divided by x squared. Okay, which means that this is not going to be eliminated. Alright, because it is going to be something like 7 over x. Okay, so this is not going to be done. So our remainder will be 7x plus 5. Okay, so the quotient of this polynomial when you divide with x squared plus 3x is equivalent to this polynomial divided by this polynomial is equivalent to the answer that we have here, which is x minus 3 together with the remainder divided by the divisor that we have before. Okay, right? So if you would like to compare, for example, let's say you have 3 divided by 2. Okay, 3 divided by 2. Okay, so when you have 3 divided by 2, what do you do is you have 1, and 1 multiplied by 2 is equivalent to 2, and then you have this one as the remainder. So what you can say is that 3 over 2 is equivalent to 1 plus 1 over 2. So that is the same as what we have here. Okay, so this is going to be the answer that we have above is x minus 3, and then the remainder that we have is 7x plus 5, and the divisor that we are having is still the same of x squared plus 3x. Okay, so that is how you put it into form of fraction. And if you want to change it into non-fraction answer, that will be just multiplying back this one with the whole thing, the divisor with the whole thing. So that's why we have x minus 3 times by the divisor of x squared plus 3x plus by the remainder of 7x plus 5. Okay, so you can also write it as this one. Okay, so that is what we do for long division process of polynomials. Okay, so I'm going to show you another example, maybe by using one question from exercise 1.6. Okay, I'm going to use one exercise from 1.6, which is number 4. Maybe we'll start with B. Okay, I'm going to show you the example for B. Okay, so the question here is 2x squared plus 3x minus 4 divided by 2x plus 1. Okay, so that is the question. You can see that the numerator degree is 2 and the denominator degree is 1. Okay, the divisor degree is 1. The polynomial that we have above is 2x to the power of 2x to the power of 2. So the degree is higher. So now you have 2x squared and 2x. What you do is you are going to have 2x squared. When you divide by 2x, what do you get? It's going to be x. So you can just put x over here. But before that, check first. This is the degree of 2, degree of 1 and degree of 0. So it's already complete here. If you are not having complete polynomial yet, please add on. Okay, please add on. Right, so this is going to be x times by 2x is equivalent to 2x squared. X times by 1 is equivalent to positive x. And when you minus the one that you have here, it will be 0. 3x minus x is equivalent to 2x. And then we copy what we have here before we proceed. So we have 2x minus 4. Okay, so 2x minus 4. So 2x divided by 2x is equivalent to 1. Okay, so this will be 1 times by 2x is equivalent to 2x, and 1 times by 1 is equivalent to positive 1. So when you minus this one, you will be getting 0. 2 minus 2 is 0. And then negative 4 minus by 1 is equivalent to negative 5. Okay, so the final answer for this one would be if you want to write it as a fraction, then it will be 2x squared plus 3x minus 4 divided by 2x plus 1 is equals to the answer that we have, x plus 1 plus by the remainder of negative 5 over the divisor of 2x plus 1. Okay, so you can see that this is supposed to be written in the simplified term, which is equals to x plus 1 minus by 5 over 2x plus 1. Okay, so this is one of the way of writing the answer. Or if you want to have another way of writing it, it can also be written as 2x squared plus 3x minus 4 is equivalent to 2x plus 1 times by x times by x plus 1 And then we have minus 5. Okay, so that is also another way of writing this one. Okay, so this is the first way, which is the fraction form, and this is another form of writing the answer, which is given as before, which is this one. So this is your pre-x, this is your quotient. Sorry, this is not the quotient, this is the divisor if you want to write as what is given. Okay, so this is the divisor, and this is all the quotient that you have, and the remainder is given here. Okay, so this can either be written as qx multiplied by this to either or. Okay, alright, so that's all for now. I'm hoping that you can try to do the division of polynomials by your own, but make sure that you rearrange whatever is supposed to be rearranged, especially when it comes to the degree of the polynomial. When they are not enough yet, I mean it is not written in order, please do add the term with degree of in order, which means that if you start with x to the power of 3 and then the next one is to the power of 1, what you need to do is to make sure that you put an extra term of 0 times by x to the power of 2, something like this. Okay, right, so that's all for now. Thank you.